Good afternoon, learners. Welcome to the first lesson of reactions of metals with oxygen. I hope you're staying safe and staying home and also following the right measures. Okay, so what I want us to do now is to watch a video and we will proceed with the lesson. Okay, I think we can start now. I want to ask you guys a question. What do you think happens when we light up fireworks?
They blast off into the sky and explode.
Can you repeat that?
They blast off into the sky and explode.
Do you know what makes them to do that?
No.
The reason why fireworks blast off into the sky and explode is because they have metals, and these metals, when you light them up, they blow off into the sky where they react with oxygen, causing a big explosion. Does anyone have a question?
How do they create different colors and create different colors and shapes?
Yes, the different colors and patterns are due to the fact that these metals are arranged in a way that they blow at different times. So that is why they create these shapes and designs. In terms of colors, the reason for colors is because different metals give off different colors when they burn. For example, copper gives off a greenish blue color, while magnesium gives off a bright white color. Which takes us to the subject of today's lesson. We want to talk about combustion. What happens with fireworks is a form of combustion. Combustion is a process through which metals are burned in the presence of oxygen. Generally, when we have reactions of oxygens with metals, we get the products are metal oxide. So for example, if you react a metal and an oxygen, you get a metal oxide. For example, if you have sodium and you react it with oxygen, you will get sodium oxide. If you have potassium and then you react it with oxygen, you get potassium oxide. So if you react calcium and oxygen, what do you get?
Calcium oxide.
Exactly. So the fourth equation is the reverse of what we have been doing. If I have iron oxide, it means this is the reaction between oxygen and
iron.
Great. So now what is going to happen now is that I'm going to allow you to watch a video, and while watching this video, you have to complete a section of the worksheet. The section that you have to complete is the one that asks you questions about what is happening in the video. This worksheet is given to you via Google Docs. The link will be included in the notes. Moving on, we're going to talk about balancing equations. I'm sure you're all familiar with balancing equations. Let us look at the equation on the screen. Is it balanced or is it not balanced?
It is balanced.
Yes, it is balanced. How do you know that? Which law do we follow when we balance equations?
The law of conservation of matter.
Exactly. The law of conservation of matter states that matter cannot be created nor destroyed. So for the balancing of equations, what does this law of matter mean? Law of conservation of matter mean for us?
It means that the number of atoms on the left side of the equation should be equal to number of atoms on the right.
Exactly. So let's take an example from your periodic table. Looking at the periodic table, we know that metals are located from the left side of the periodic table as well as on the vertical column. So let's take sodium, for example. If we react sodium and oxygen, we get sodium oxide. So now we have to balance the equation. The equation on the screen is balanced, right?